Welcome to our countdown of the top 10 dinosaurs you need to know about. Welcome to Scroll 10. Today we embark on an extraordinary voyage, journeying back hundreds of millions of years to a time when colossal beings roamed this planet. It was an era of unparalleled scale, a world teeming with life forms so magnificent, so utterly alien to our modern sensibilities, that they continue to ignite our imaginations and fuel our scientific curiosity. These are not mere monsters of myth, but living, breathing creatures that shaped the ecosystems of their time, leaving behind a legacy etched in stone, a testament to the Earth's ever-evolving story. From the mighty T-Rex, whose very name evokes terror and awe to the gentle giants, the long-necked sauropods that browsed the prehistoric treetops, we've got them all. We will explore their unique adaptations, their behaviors, and the ancient landscapes they inhabited. Imagine a world bathed in the warm glow of a younger sun, where ferns grew as tall as trees, and the air thrummed with the calls of creatures unlike any seen today. This journey is more than just a list. It's an immersion into the deep past. A chance to understand the forces that drove evolution and the incredible diversity of life our planet can foster. Join us as we peel back the layers of time, guided by the fossil record and the tireless work of paleontologists who piece together these prehistoric puzzles. We'll marvel at their sheer size, their incredible power, and the ingenious ways they survived in a world that was both beautiful and brutal. Prepare to witness the grandeur of the Mesozoic era, to meet its most iconic inhabitants, and to perhaps feel a profound connection to these ancient rulers of the Earth. The story of dinosaurs is, in many ways, the story of life's resilience and its boundless capacity for innovation. Our journey into the heart of the dinosaur age commences with a creature whose reputation precedes it, a name that resonates with power and primal fear. Tyrannosaurus rex. Standing over 12 feet tall at the hips and measuring up to 40 feet in length, this colossal carnivore dominated the late Cretaceous period, approximately 68 to 66 million years ago. Its very posture, a bipedal stance balanced by a long, heavy tail, speaks of an agility that belies its immense size, a predator perfectly engineered for its role at the apex of its ecosystem. The lands it roamed were vastly different from our own, a mosaic of forests and floodplains across what is now western North America. The most formidable feature of Tyrannosaurus rex was undoubtedly its massive skull, nearly 5 feet long, housing jaws of incredible strength. Within these jaws were some 60 dagger-like teeth, serrated and up to 9 inches in length, designed not merely to slice, but to crush bone. Scientific estimates suggest a bite force unparalleled by almost any other terrestrial animal, capable of exerting thousands of pounds of pressure. This wasn't just a hunter, it was a biological superweapon, a testament to the evolutionary arms race that defined the Mesozoic. Its keen senses, including excellent binocular vision for depth perception and a highly developed sense of smell, would have made it an incredibly efficient predator. Much debate has surrounded the lifestyle of T-Rex. Was it an active hunter, pursuing formidable prey like Triceratops and Edmontosaurus? Or was it primarily a scavenger, using its intimidating presence to usurp kills from smaller carnivores? The current scientific consensus leans towards a versatile opportunist, capable of both hunting down large herbivores and scavenging carcasses when available. Evidence of healed bite marks on prey fossils suggests active predation, while its robust build could have allowed it to intimidate rivals and claim their meals. This adaptability likely contributed to its reign as a top predator for millions of years. The forelimbs of T-Rex, famously diminutive with only 2 functional digits, have long puzzled scientists and intrigued the public. While seemingly disproportionate to its massive body, they were not useless. Muscular and equipped with sharp claws, they may have played a role in grasping struggling prey at close quarters, or perhaps in helping the animal rise from a resting position. Every feature of T-Rex, from its powerful legs designed for striding across its domain, to its reinforced skull built to withstand immense stresses, paints a picture of an animal supremely adapted to its environment and its predatory niche. The discovery of T-Rex fossils, beginning with Barnum Brown in the early 20th century, revolutionized our understanding of dinosaurs and captured the global imagination. Each new find, from nearly complete skeletons to fossilized footprints and even coprolites, adds another piece to the puzzle of this magnificent creature's life. It remains a potent symbol of the ancient world, a reminder of the sheer scale and ferocity that life on Earth can achieve, and a constant source of wonder for all who contemplate the deep history of our planet. Its reign may have ended with a cataclysmic asteroid impact, but its legacy endures. From the undisputed king of carnivores, we turn our attention to one of its most formidable contemporaries, a true icon of the herbivorous dinosaurs Triceratops. Its name, meaning three-horned face, aptly describes its most striking feature: two long brow horns above its eyes and a shorter, robust horn on its snout. These were not mere ornamentation. They were potent defensive weapons, capable of inflicting serious damage upon any predator foolish enough to challenge this heavily built creature. Roaming the same late Cretaceous landscapes of North America as T-Rex, Triceratops was a common sight, a vital part of the ecosystem. Measuring up to 30 feet in length and weighing as much as 12 tons, Triceratops was a quadrupedal giant built like a prehistoric tank. Its immense head, one of the largest of any land animal, could reach nearly a third of its body length and was adorned with a magnificent bony frill. This frill, extending from the back of its skull, has been the subject of much scientific discussion. It likely served multiple purposes: as a shield to protect its vulnerable neck, a display structure for species recognition or attracting mates, and perhaps even as an anchor for powerful jaw muscles, aiding in the processing of tough plant material. Triceratops was a dedicated herbivore equipped with a powerful beak-like mouth and rows of shearing teeth, perfectly adapted for cropping and grinding the fibrous vegetation of the late Cretaceous, such as ferns, cycads and palms. It likely browsed on low-growing plants, using its immense bulk and strength to push through dense undergrowth. Evidence from bone beds suggests that Triceratops may have lived in herds, or at least congregated in groups, which would have offered additional protection against predators. Imagine a phalanx of these horned giants, presenting an almost impenetrable wall of defense. The relationship between Triceratops and Tyrannosaurus rex is one of the most famous predator-prey dynamics in Earth's history. Fossil evidence, including T-Rex tooth marks on Triceratops bones and even healed injuries on Triceratops frills and horns, paints a vivid picture of epic confrontations. While a lone T-Rex might have hesitated to attack a healthy adult Triceratops, the young, old or sick would have been prime targets. The horns and frill were crucial adaptations in this constant battle for survival, a clear example of coevolution shaping these magnificent beasts. The discovery of numerous Triceratops fossils, ranging from hatchlings to full-grown adults, has provided paleontologists with a wealth of information about its growth, behavior, and variation within the species. Some specimens show signs of combat, with puncture wounds and fractures on their frills and horns, suggesting that these animals not only defended themselves against predators, but also engaged in intraspecific combat, perhaps for territory or mating rights. Triceratops stands as a testament to the diversity and resilience of herbivorous dinosaurs, a true heavyweight of the prehistoric world. Our next subject is a dinosaur whose popular image, largely shaped by cinema, often overshadows its true yet equally fascinating nature velociraptor. The name itself, meaning swift seizer or swift plunderer, hints at its predatory prowess. Living during the late Cretaceous period, around 75 to 71 million years ago, Velociraptor inhabited the arid desert-like environments of what is now Mongolia and China. Far from the human-sized terrors of film, the real Velociraptor was a much smaller, though no less formidable creature. It stood perhaps only 2 feet tall at the hip and measured around 6 to 7 feet in length, much of which was its long, stiffened tail. One of Velociraptor's most distinctive features was the large, sickle-shaped claw on the second toe of each foot. This retractable claw, which could be up to 3 inches long, was held off the ground while walking, keeping it razor-sharp. It was not primarily for disemboweling large prey, as often depicted, but more likely used to pin down smaller animals, or perhaps to slash and inflict deep wounds on larger quarry, or even to help climb onto struggling victims. This specialized weapon, combined with its agile build, made Velociraptor a highly efficient hunter of small to medium-sized prey, such as protoceratopses or small mammals and reptiles. Perhaps the most significant revelation about Velociraptor and its close relatives, the Dromaeosaurids, is the strong evidence suggesting they were covered in feathers. Fossil discoveries of related species like Microraptor and Genuanlong show clear impressions of well-developed plumage, including long feathers on their arms and tails. While direct feather impressions haven't been found for Velociraptor mongoliensis itself, quill knobs, attachment points for feathers found on the ulnar bone of modern birds, have been identified on Velociraptor forearms. This indicates that these dinosaurs likely sported a coat of feathers, perhaps for insulation, display, or even to aid in maneuvering while pouncing on prey. Velociraptors were intelligent predators, possessing relatively large brains for their body size, suggesting complex behaviors. It's widely believed they may have hunted cooperatively, in small packs, using strategy and coordination to tackle prey that might be too challenging for a solitary hunter. The famous fighting dinosaurs fossil, which preserves a velociraptor locked in combat with a protoceratops, provides a dramatic snapshot of its predatory life, capturing a moment of intense struggle frozen in time. This remarkable find shows the velociraptor's sickle claw embedded in the throat of the protoceratops, while the herbivore appears to have crushed the predator's arm in its powerful beak. Despite its smaller stature compared to its cinematic counterpart, the true velociraptor was a marvel of predatory evolution. Its keen eyesight, sharp claws, intelligence, and probable feathered covering paint a picture of a highly adapted and successful dinosaur. It represents a fascinating branch of the dinosaur family tree, one that highlights the close evolutionary link between dinosaurs and modern birds, reminding us that the legacy of these ancient creatures is still with us today, soaring through our skies. We now venture further back in time to the late Jurassic period, approximately 155 to 150 million years ago, to encounter one of the most recognizable and bizarrely adorned dinosaurs, Stegosaurus. Its name, meaning roof lizard or covered lizard, refers to the distinctive double row of large, kite-shaped bony plates, known as scutes, that ran along its arched back and tail. These plates, embedded in the skin rather than directly attached to the skeleton, have long been a source of fascination and scientific debate, making Stegosaurus an unmistakable figure in the prehistoric panorama of what is now North America and Europe. Stegosaurus was a large, heavily built herbivore, reaching lengths of up to 30 feet and weighing several tons. It moved ponderously on 4 stout legs, with its hind limbs significantly longer than its forelimbs, giving it a characteristically arched back and a low-slung head. This posture suggests it primarily fed on low-growing vegetation such as cycads, ferns and conifers, which it would have stripped with its toothless, horny beak and processed with small, peg-like cheek teeth. Its brain was famously small, often compared to the size of a walnut, leading to early theories of it being a slow, unintelligent creature, though brain size alone is not a definitive measure of intelligence or behavioral complexity. The function of Stegosaurus's iconic plates has been a subject of much speculation. Early theories proposed they were for protection, forming a kind of armor. However, their relatively thin structure and rich blood vessel network suggest other possibilities. One prominent theory is that they served as thermoregulatory devices, helping the large animal to absorb solar heat or dissipate excess body heat. Another compelling idea is that they were primarily for display, used to make the animal appear larger and more intimidating to predators, or to attract mates and recognize members of its own species, much like the elaborate plumage of some modern birds. Beyond its impressive plates, Stegosaurus possessed another formidable feature: the thargomizer. This term, humorously coined from a Far Side cartoon, refers to the arrangement of 4 to 10 sharp, bony spikes, each up to 2 feet long at the end of its muscular tail. Unlike the plates, there is direct fossil evidence supporting the thagomizer's role as a defensive weapon. Puncture wounds on predator fossils, such as Allosaurus, match the size and spacing of Stegosaurus tail spikes, indicating that it could swing its tail with considerable force and accuracy to defend itself against attackers. Stegosaurus fossils, first discovered in the 1870s during the Bone Wars in the American West, have provided valuable insights into the diverse ecosystems of the Jurassic period. It shared its world with giant sauropods and formidable theropods, carving out its niche as a well-defended, low-browsing herbivore. The unique and somewhat enigmatic appearance of Stegosaurus continues to captivate us, a testament to the extraordinary range of forms that life took during the age of dinosaurs, each adaptation a response to the pressures and opportunities of its ancient environment. Our exploration now takes us to the waterways of the Cretaceous period between 112 and 93.5 million years ago to meet a dinosaur that challenges our traditional image of these terrestrial giants, Spinosaurus. This colossal theropod, whose name means spine lizard, is renowned for the enormous sail-like structure on its back, formed by neural spines extending up to 5.5 feet from its vertebrae. Recent discoveries have dramatically reshaped our understanding of Spinosaurus, revealing it as a creature uniquely adapted to a semi-aquatic lifestyle, a true river monster of the prehistoric world, primarily inhabiting the mangrove swamps and river systems of what is now North Africa. Spinosaurus may well have been the largest of all carnivorous dinosaurs, potentially exceeding even Tyrannosaurus rex in length, with some estimates suggesting it could reach over 50 feet. Its most striking feature, the dorsal sail, remains a topic of scientific discussion. It could have been used for display, to intimidate rivals or attract mates, or perhaps for thermoregulation, absorbing heat or radiating it away. Given its likely aquatic habits, it might also have aided in stabilization while swimming, or even served as a visual signal above the water's surface, much like the dorsal fin of a shark. The anatomy of Spinosaurus points strongly towards a life spent largely in and around water. It possessed a long, narrow snout, similar to that of modern crocodiles, filled with conical, unserrated teeth, ideal for gripping slippery prey like fish. Isotope analysis of its bones suggests a diet rich in aquatic animals. Furthermore, its nostrils were positioned high on its skull, allowing it to breathe while partially submerged. Its dense bones provided buoyancy control, and its paddle-like feet, possibly webbed, and a fin-like tail recently discovered, would have made it a powerful swimmer, perfectly suited for hunting in the vast river systems it called home. The story of Spinosaurus is also one of scientific rediscovery and resilience. The first and most complete specimen was discovered in Egypt in the early 20th century by Ernst Stromer, but was tragically destroyed during a bombing raid in Munich in World War II. For decades, our knowledge was limited to Stromer's detailed drawings and descriptions. However, new fossil finds in Morocco in recent years, including parts of the skull, limbs, and crucially, the tail, have provided a much clearer picture of this extraordinary animal, confirming its aquatic adaptations and its status as a truly unique predator. Spinosaurus shared its environment with other giant predators, such as Carcharodontosaurus, and massive freshwater creatures like the coelacanth morsonia and the sawfish Onchopristis, the latter likely forming a significant part of its diet. This predator wasn't just wading in the shallows, it was an active pursuit hunter in the water, a niche previously unrecognized for large theropods. Spinosaurus forces us to rethink the diversity of dinosaur lifestyles, showcasing their ability to conquer not just the land, but also the aquatic realms of the Mesozoic world. While not strictly dinosaurs in the formal scientific classification, no exploration of the Mesozoic's most magnificent creatures would be complete without acknowledging the rulers of the prehistoric skies. We now look upwards to Pteranodon, one of the best-known pterosaurs, or flying reptiles. Soaring over the shallow seas of the late Cretaceous period, around 86 to 84.5 million years ago, primarily in what is now North America, Pteranodon was a truly spectacular sight, a testament to the evolution of vertebrate flight on an impressive scale. Its name means wing without tooth, referring to its toothless beak, a characteristic that distinguishes it from earlier pterosaurs. Pteranodon was a large pterosaur with an impressive wingspan that could reach up to 23 feet, and in some larger males perhaps even more. Its wings were not formed of feathers like those of birds, but of a leathery membrane of skin and muscle, known as a patagium, stretched between its elongated fourth finger and its body and hind limbs. Despite its large wingspan, Pteranodon was relatively lightweight, with hollow bones, an adaptation crucial for flight. It was a master of soaring, likely using thermal updrafts and sea breezes to glide effortlessly over vast distances in search of prey. The most distinctive feature of Pteranodon, aside from its wings, was its prominent cranial crest. The size and shape of this crest varied significantly, with some individuals, believed to be males, sporting large blade-like crests extending backwards from the skull. Females and younger individuals typically had smaller, more rounded crests. The function of this crest has been debated, but it likely served as a display structure for species recognition and sexual selection. It may also have acted as a counterbalance to its long beak or even as a rudder, aiding in steering during flight, though the latter is less certain. Pteranodon was a specialized piscivore, meaning it primarily fed on fish. Its long, pointed, toothless beak was perfectly adapted for snatching fish from the surface of the water as it swooped down from above, much like modern pelicans or gannets. Fossil evidence, including fish scales and bones, found in the stomach region of Pteranodon specimens, confirms this dietary preference. It likely nested in colonies on coastal cliffs or islands, venturing far out to sea to hunt in the western interior seaway, a vast inland sea that once covered much of central North America. The discovery of numerous Pteranodon fossils, often in excellent states of preservation, has provided invaluable insights into the anatomy, flight capabilities, and lifestyle of these magnificent flying reptiles. They represent a highly successful group that dominated the skies for millions of years, showcasing an independent evolutionary path to powered flight, distinct from that of birds and bats. Pteranodon, with its majestic silhouette against the Cretaceous sky, remains an enduring symbol of the diverse and awe-inspiring life forms that inhabited our planet long before humans. We now turn our gaze to a creature of truly staggering proportions, a dinosaur that redefines our understanding of biological limits, Argentinosaurus quinculensis. This colossal sauropod, whose name simply means Argentine lizard, roamed the lands of what is now Patagonia, Argentina, during the late Cretaceous period, approximately 97 to 93.5 million years ago. Argentinosaurus is considered one of the largest, if not largest, land animals ever to have walked the Earth. Its sheer scale is difficult to comprehend, a living mountain of flesh and bone that would have dwarfed even the largest modern elephants. Estimating the exact size of Argentinosaurus is challenging due to the incomplete nature of its fossil remains, primarily vertebrae, ribs and a tibia. However, based on these colossal bones, paleontologists project lengths of around 100 to 115 feet, possibly even more, and weights that could have reached 70 to 100 tons. Imagine a creature as long as 3 school buses parked end to end and weighing as much as a dozen adult African elephants. Its vertebrae alone were immense, some measuring over 5 feet in height and width, built to support its incredible mass and long neck. Like other sauropods, Argentinosaurus was a quadrupedal herbivore, with a long neck that allowed it to browse on vegetation inaccessible to most other plant eaters. It likely fed on the foliage of tall conifers and other prehistoric trees, stripping leaves with peg-like teeth and swallowing them whole, to be ground down by gastroliths, stomach stones, in its enormous gut. The energy requirements for such a massive animal would have been immense, necessitating almost constant feeding. Its immense size would have also made it a formidable challenge for any contemporary predator, though young or sick individuals might have been vulnerable. The environment Argentinosaurus inhabited was a warm, humid landscape with vast floodplains and forests, capable of supporting the enormous quantities of vegetation needed to sustain such giants. Evidence from fossilized nesting sites of related titanosaurs suggests that these colossal animals laid clutches of numerous, relatively small eggs. The hatchlings would have been tiny compared to the adults, facing immense challenges to survive and grow to their parents' monumental size. Their growth rate must have been incredibly rapid to reach such proportions within a lifetime. The discovery of Argentinosaurus in the early 1990s pushed the known boundaries of dinosaur size and continues to inspire awe. It represents the pinnacle of sauropod gigantism, a testament to the evolutionary pressures and ecological opportunities that allowed such creatures to thrive. Studying these titans provides invaluable insights into the biomechanics of large animals, their physiology, and the ecosystems that supported them. Argentinosaurus reminds us that the history of life on Earth is a story of incredible scale and breathtaking diversity, where giants once truly shook the ground with every step. Our next dinosaur is a veritable fortress on 4 legs, a herbivore so well defended that few predators would have dared to challenge it. Ankylosaurus magniventris. Its name, meaning fused lizard due to the fused bones in its skull and other parts of its body, and great belly referring to its wide girth, perfectly encapsulates its robust and heavily armored nature. Living during the very end of the late Cretaceous period, between 68 and 66 million years ago, Ankylosaurus roamed the western regions of North America, a contemporary of Tyrannosaurus rex and Triceratops, and one of the last non-avian dinosaurs. Ankylosaurus was a large animal measuring up to 30 feet in length and weighing an estimated 6 to 8 tons. Its entire upper body, including its head and even its eyelids, was covered in a formidable mosaic of bony plates, knobs and spikes known as osteoderms embedded in its thick, leathery skin. This dense armor provided exceptional protection against the powerful jaws and sharp claws of predators. Its low-slung, wide body and short, powerful limbs further contributed to its tank-like appearance, making it incredibly difficult to flip over and expose its more vulnerable underside. The most distinctive defensive weapon of Ankylosaurus was its massive tail club. This formidable structure was formed by several large osteoderms fused to the last few tail vertebrae, creating a heavy bony knob. The tail itself was stiffened by interlocking vertebrae and ossified tendons towards its end, allowing the animal to swing the club with considerable force and precision. This tail club could have been used to deliver devastating blows to the legs or ribs of an attacking theropod, potentially breaking bones and deterring even the most persistent hunters. It was a purely defensive adaptation, a clear message to any carnivore: stay away. Ankylosaurus was a herbivore equipped with a broad, shovel-like beak for cropping low-growing vegetation and small leaf-shaped teeth for mashing plants. Its wide muzzle suggests it was a non-selective browser, feeding on a variety of ferns, cycads and flowering plants. Given its low-slung head and heavy build, it likely grazed in a slow, deliberate manner, relying on its armor rather than speed to protect it from danger. Its complex nasal passages may have played a role in olfaction, vocalization, or even cooling the air it breathed. Despite its iconic status and fearsome reputation, complete Ankylosaurus skeletons are relatively rare. Much of what we know is pieced together from partial remains, including skulls, armor plates, and its famous tail club. Each discovery helps to refine our understanding of this remarkable creature's anatomy and lifestyle. Ankylosaurus represents a pinnacle of defensive evolution among dinosaurs, a walking bastion that showcases the incredible diversity of survival strategies employed by herbivores in a world dominated by giant carnivores. Its presence right up to the KPG extinction event marks it as one of the final expressions of dinosaurian grandeur. We now turn to a dinosaur whose name is as captivating as its appearance, a creature that seems to have leaped from the pages of mythology, Draciorex hogwartsia. Its genus name, Draciorex, means dragon king, while the species name Hogwartsia honors the fictional Hogwarts School of Witchcraft and Wizardry from the Harry Potter series, a nod to its dragon-like skull. Discovered relatively recently in the Hell Creek Formation of South Dakota, USA, Draciorex lived during the late Cretaceous period, around 66 million years ago, making it one of the last dinosaurs to walk the Earth before the Great Extinction event. Draciorex is known primarily from a remarkably well-preserved skull and a few cervical vertebrae. The skull is its most striking feature, flat and wedge-shaped, adorned with an array of spikes, knobs and horns, giving it a distinctly draconic visage. It lacked the prominent dome, typical of other pachycephalosaurs or bone-headed dinosaurs to which it belongs. Instead, its skull roof was thick and ornamented with a pair of large openings, supratemporal fenestrae, on top. This unique cranial morphology has sparked considerable scientific debate and fascination since its unveiling. The primary debate surrounding Draciorex centers on its validity as a distinct species. Some paleontologists, notably Jack Horner, have proposed that Draciorex, along with another similar pachycephalosaur named Stygimoloch, may not be unique genera, but rather juvenile or subadult growth stages of the well-known Pachycephalosaurus. According to this hypothesis, the flat, spiky skull of Draciorex would represent an early stage, which would then develop into the spiky domed skull of Stygimoloch, eventually maturing into the fully domed skull of an adult Pachycephalosaurus as the spikes receded and the dome thickened. This theory of ontogenetic morphing suggests a dramatic transformation throughout the animal's life. If Dracorex is indeed a juvenile Pachycephalosaurus, its elaborate cranial ornamentation at a young age is intriguing. These spikes and knobs might have served for species recognition or display even before the development of the thickened dome, which is traditionally thought to have been used in headbutting contests either for territory or mates, much like modern bighorn sheep. The study of Dracorex thus provides a window into the complex growth patterns and social behaviors of these unique herbivorous dinosaurs. It highlights how our understanding of dinosaur diversity can evolve as new evidence and interpretations emerge. Regardless of its ultimate classification, the discovery of the Dracorex skull has added another fascinating character to the late Cretaceous bestiary. It was likely a bipedal herbivore, relatively small compared to many of its contemporaries, perhaps around 10 feet in length. It shared its world with giants like Tyrannosaurus rex and Triceratops, navigating a complex ecosystem. The Dragon King continues to enchant and challenge scientists, reminding us that even in well-studied formations, new and surprising discoveries can still rewrite chapters of prehistoric life, sometimes with a touch of whimsy in their naming. Our final dinosaur in this countdown is a true fan favorite, a gentle giant whose towering form has captured imaginations for generations, Brachiosaurus. Its name, meaning arm lizard, refers to its unusually long forelimbs, which were significantly longer than its hind limbs. This unique anatomy gave Brachiosaurus a distinct giraffe-like posture with a steeply inclined back and a neck that naturally angled upwards, allowing it to reach vegetation far above the ground. It lived during the late Jurassic period, around 154 to 153 million years ago, primarily in what is now North America and possibly Africa, though African specimens are now often assigned to the related genus Giraffatitan. Brachiosaurus was an enormous sauropod, reaching lengths of up to 85 feet and standing perhaps 40 to 50 feet tall, making it one of the tallest known dinosaurs. Its weight is estimated to have been between 30 and 60 tons. The most iconic feature was undoubtedly its incredibly long neck, held high, allowing it to browse on the leaves and branches of the tallest trees, such as conifers, cycads, and ginkgos, a food source inaccessible to most other contemporary herbivores. This high-browsing niche meant it likely faced little competition for food from other plant eaters in its ecosystem. The physiology of Brachiosaurus presents some fascinating biological challenges. Pumping blood all the way up that long neck to its brain would have required an exceptionally powerful heart and a very high blood pressure. Its nostrils were located high on its skull, near the eyes, leading to early, now largely discredited theories that it might have been aquatic, using its nostrils like a snorkel. However, current understanding firmly places Brachiosaurus as a terrestrial animal, its anatomy perfectly suited for life on land, reaching for the highest foliage. Its broad, chisel-like teeth were adapted for stripping leaves from branches. Brachiosaurus lived in a world of giants, sharing the Morrison Formation ecosystem with other massive sauropods like Diplodocus and Apatosaurus, as well as formidable predators such as Allosaurus and Torvosaurus. Its immense size would have been its primary defense against these carnivores. As a healthy adult, Brachiosaurus would have been an incredibly challenging, if not impossible, target for most predators. Like other sauropods, it likely laid eggs in nests, and the young would have been vulnerable, needing to grow quickly to achieve the safety of size. The image of Brachiosaurus, with its majestic neck reaching towards the sky, embodies the grandeur and scale of the dinosaur age. It was one of the first giant sauropods to become widely known to the public, and its distinctive silhouette remains instantly recognizable. It represents a marvel of biological engineering, a creature perfectly adapted to its specialized feeding strategy. As we conclude our journey, Brachiosaurus stands as a fitting testament to the awe-inspiring diversity and sheer magnificence of the creatures that once dominated our planet, leaving an indelible mark on the story of life. And so our journey through the Mesozoic era, a breathtaking tour of 10 of the most remarkable dinosaurs to have ever graced our planet, draws to a close. Thanks for joining us on this prehistoric journey. From the colossal Argentinosaurus that shook the earth with its passage to the feathered cunning of Velociraptor and the sky-soaring Pteranodon, we have witnessed but a fraction of the incredible diversity that characterized the age of dinosaurs. These magnificent creatures, rulers of the Earth for over 150 million years, tell a profound story of adaptation, evolution, and ultimately, the ever-changing nature of life itself. The fossils they left behind are more than just ancient bones. They are windows into lost worlds, challenging our understanding and igniting our curiosity. The study of these animals continues to evolve with each new discovery, each technological advancement, painting an ever clearer picture of how they lived, how they interacted, and the environments they shaped. Their story is a vital part of our planet's heritage, a reminder of the immense timescales over which life has unfolded and the extraordinary forms it can take. The legacy of the dinosaurs is all around us, not only in the birds that fill our skies, their direct descendants, but also in the enduring sense of wonder they inspire. We hope this exploration has deepened your appreciation for these ancient titans and the world they inhabited. Don't forget to like, share, and subscribe for more amazing content as we continue to delve into the wonders of the natural world, past and present. The story of life on Earth is a vast and captivating epic, and there are always more chapters to explore. Which dinosaur is your favorite from our list? Or is there another that captures your imagination? Don't forget to like, share, and subscribe to Scroll 10 for more fascinating content. Let us know in the comments below. Until next time, keep exploring, keep questioning, and keep wondering.